There is a new feature library for parallel programming in VNext. You have released the second official build of TPL Dataflow.
Yeah.
Can you explain the motivation of TPL Dataflow?
Sure. Yeah, TPL Dataflow is a cool technology. You can kind of trace its roots back if you were to figure out who its mother is. Has a couple different major parents, I guess. One is the concurrency coordination runtime, the CCR, that came out of the robotics team at Microsoft, which that team built to control robots, Lego Mindstorms and all that kind of thing. But it turned out it was a really great way to build in tolerances for asynchronicity and latencies, and to design around the flow of data. The programming model they had was unusual. But a lot of people really liked it. It took some grokking for people sometimes to get a hold of. The other direct parent, I guess, would be the agents library in Visual C++ that we shipped in Visual C++ 2010. So asynchronous agents
agent
and CCR. Yeah, the name almost flew out of my head. And this idea, and then the genesis goes back decades in computer science research to more general agent message type models, where you have rather than the idea is as we've become accustomed to designing around execution flow with threads and thinking about how, okay, I need to spawn off a thread to go do this thing or this thing, and then we end up putting locks in our code because, well, I have this one piece of data and I want to write to it, so I need to lock it so I can write to it so that these other threads don't read to it at the same time. But when I lock it, then all these other threads just come to a screeching halt and have to wait, and then my code gets really complex. And then parallel programming is interesting because of these complexity problems. I can have two working pieces of parallel code that when I try to use them together, they break. The sum of the parts no longer works as a whole. So this is this kind of problem that we mean to get around with something like TPL Dataflow, where you can have a more data-centric mentality in terms of your design. If you're designing around agents that operate asynchronously from one another, and you no longer have the assumption that they're sharing data, instead you're passing messages between these things, then you find yourself in a place where you don't need to put all these locks in your code. You have messages, you have message queues that are enforcing ordering in terms of how things interact with one another, and you could build networks of these things, such that data pipelines where you can, for example, let's take the loading a bunch of files or whatever. You can start doing this, and as you generate packets of data, start passing them down in the flow. Next stage can then process on that message, transform it, do whatever it needs, pass it on in the flow. And you get these nice data pipelines where messaging enforces ordering and message queues enforce ordering, but each stage is an opportunity for latent parallelism. If I have a multi-core machine, suddenly I have the ability to start doing reads over here while I'm doing writes over here. Instead of making this whole thing synchronous, I can build asynchronicity into the system and do it in a way that is composable, because I can use these pieces of code together, two correct pieces of code compose into one bigger correct piece of code, and it's maintainable over time. Whereas threaded code, a year later when you revisit some gnarly threaded code, it can be really difficult to figure out, like, okay, what were all the little subtleties I was trying to bake into this locking system. You just don't have to worry about those things. So the complexity goes down. Your ability to write cooler systems that scale better in less time and are easier to maintain over time just goes way up.
Do you think TPL Dataflow will be more appreciated by developers than TPL itself?
That's a good question. So TPL itself is an improvement on threads or thread pool programming model, because we start talking about tasks. And tasks let us, instead of thinking about execution flow, tasks are better because we can think in terms of just work. This is a task, this is a chunk of work, and this is a task, and this is another chunk of work. And then I can have waits and continuations where I can compose these tasks together. You got to do this before this, and when these three are done, you could do this one, or when any of these are done, you can do this other thing. So tasks and the composition of tasks unlock a new programming model that I think is the way we do computer science education in the world today, mostly around threads and things like that. I think that the task model with TPL is more familiar to people today. Over time, I do think, whether we'll get more users of TPL Dataflow or not, I don't know. It'll take a while. But I think over time, people will get a greater appreciation for that Dataflow model because of the reduced complexity and the latent parallelism that kind of gets built into the system. Like, think the runtime can just figure out some opportunities for parallelism without me having to express it explicitly. And as core counts increase on machines, we want our software to just kind of automatically scale with that parallelism, and we want programming models that make it easy for us to do that. Yeah. So I definitely think over time these kinds of models will be greater appreciated. Yeah. With that said, the Dataflow model doesn't fit for everything.
Exactly.
So there are some problems it's really great for. Some problems it's not as good for, and for task-centric parallelism, it may or may not be good for that sort of thing where you really want to do multiple things that are quite independent from one another. It may not be the strongest model for that. What I think is going to happen in an increasing fashion, though, is people will begin to compose these different types of parallelism together. So they'll take their task parallelism and their message-based asynchronicity, either via TPL Dataflow or the new asynchronous features in the .NET languages. Yeah. They'll use these together, and then they'll use those in combination with emerging data parallel techniques, where you have, okay, I've got a really tight loop here over a piece of code. I'm manipulating matrices or whatever, and then for that, people will use increasingly vector accelerators like general purpose GPUs to go do that hardcore computation. And the trick is to come up with a way to get all of this stuff to compose together, because it's all different. Yeah. I mean, it's all parallel. Yeah. But it's very different, and then scale that out. Right now I've got data that doesn't fit on my machine, so I want to do all that stuff, but now I want to do it on a cluster, or I want to do it on the cloud. And so we find the need for both programming models and tools and the ability to manage and make these things accessible to IT pros and domain specialists goes, like, there's high value in that. Being able to solve these problems, these are hard problems, and that's really the focus from an engineering standpoint, is the focus of our organization. Like, how do we not just solve these as point solutions? It's easy to come up with a way to do GPUs, relatively speaking. It's easy to come up with a model for task parallelism or for agent message-based parallelism. But it's hard to come up with a system where all of this composes together easily and both scales up and scales out.
Yeah, you're right. I think maybe we need another book from Pattern and Practice, how to organize this kind of technology together.
So here's I'll put in a plug here. This is Stephen Tobe and Abe Miller's book. And actually both these guys work on the TC program management team. Steve Tobe is the PM for TPL Dataflow, and he's doing our team's piece of the asynchronous language stuff. He worked on the technologies in the last version of Visual Studio as well. And Abe Miller actually recently joined our team. He was in the Patterns and Practices team working on these books, and now he's the program manager for Dryad.
Oh, okay.
So if you have Dryad questions, Abe's your man.
Okay.